Okay, trying to fix this backplate on the Greeves, British hub company brake backplate, and I've managed to press a piece of copper tube, would you believe? Just plain 15mm tube. I've taken the short length, cut a slot in it so that it will collapse in on itself, because the hole in the backplate seems to be 1/2 inch nominally, so 12.5mm or so. So yeah, anyway, that was quite tough to get through. I wish now I'd put some Loctite or something on the joint, but I didn't. Anyway, just used a socket as a spacer. So there you go. Yeah, that's gone right through. So it's now sticking out both sides. I'm thinking if I peen over the edge for a start on both sides, that will help retain it, and then I'll worry about trying to bore it out or ream it out to get it back to the 1/2mm. This is the this is the cam and the spindle that needs to fit through here. So yeah, I've cleaned it up slightly, but I'll maybe give it another rub down by spinning it in the pillar drill. Get that relatively smooth and slightly smaller as well, and then work out a way of getting this through this hole. Okay. Let's see how that works. I need to rub that down a bit, and I'll try and do the same on this side, although this side there can't be much left because I can't leave much above the surface here, because the brake arm needs to fit on. Anyway, there we go. Okay, that doesn't look too bad. I mean, it's a real botch, but you never know, it might just work. The thing now is to So work out a way of getting a round hole in at the right size. Okay, I'm going to put some cyanoacrylate super glue on here. I'm hoping that it'll wick into the joint between the copper and the steel if I come in from both sides. Fairly liberal amount. Oops. I'm not sure this will do any good at all, but it's worth a try. It's quite a liquid, watery super glue, so hopefully it will wick into the joint and give it some chance of holding him. I'm worried that once I machine this out to 1/2 inch, there's not going to be much of the copper left on the inside, but I'll try and leave a lip on the two faces on this side and on this side, so at least what's left shouldn't move in or out. But yeah, we'll see. It's going to be dodgy. Good. Okay, so I've bolted the backplate to the table of this cheap mill. Well, it's an appellate really, but it's got the two-axis table on it. I'm just going to make sure that the spindle of the machine is lined up with the centre of this boss, which the cam fits into. So with this dial test gauge, it's not far off running around there. There's a lump on the boss there, but yeah, running round, it's trouble is I can't get a full cycle, but that is not too far off, or maybe it is. Yeah, that's not bad, given that I can only get round about I don't know, 100 degrees, 150 degrees. That's pretty close. Okay, so with a straight hexagon rod in the spindle, that doesn't look as if it's in the centre, but I think it probably is. Looks as if the bush that I've hammered in is probably off centre, because the spindle is centred on the outside of the boss now, thanks to the dial test indicator. So with a bit of luck, when I run a milling cutter through there, it will clear the hole out to be concentric with this outer diameter of the boss. But we will see. Okay, so I've got my tiny little milling machine. It's a really cheap one. It's basically a toy rather than any kind of real machine, but it's all I've got, so I'll make use of it. Just taken the standard chuck out. This is a Morse 2 taper, so I've managed to buy, thanks to the wonders of the internet, Morse 2 collet, which looks to be the right size. This is the drawbar, and that's 10mm I think. Yeah, that's good stuff. So that should do. I've also got a 20mm milling cutter here, and a end mill. Looks like four flutes. I've got a 20mm collet somewhere. There we go. So that should clip in there. There we go. bottoms out there, which is quite good. The copper is a terrible material to cut, but I'll take it really slowly. I'm hoping it might work. Still a fair way to go. So we're down to almost breaking through. Yeah, it's through. Well, I'm amazed that that works, but so far so good. It does look as if I've got copper all the way around, so it was pretty well centred. Spending some time with the dial test indicator and working off the outside of the boss does seem to have paid off. There you go. I'm quite surprised that that's worked as well as it seems to have done. Still some way to go, but yeah, I mean there's copper all the way around, so it's pretty well centred. But of course that's now too small. Here's the cam and the spindle. That's not going to fit in there at the moment. Again, it's not too far off. I'm hoping that with a reamer I can just open that out far enough to get this in a nice snug running fit. So I'll just whip this back on the mill. I'll just flatten that surface as well. So here's the adjustable reamer. As usual, there's a nut at either end. Okay, so yeah, measuring this spindle, there is 0.481 inches. This way is 485, maybe 486. So there's only 5 thou difference. Which is what, 1/8 millimetre? Yeah, 486. So it's not, I mean it is oval, but it's not excessively so. And it's not a critical, high profile application, so I think it'll be okay. Okay, so I've decided to use the drill press stroke milling machine for reaming as well, just to keep the reamer vertical. It's actually got to a point, having adjusted up a bit, it's actually cutting now. So let's another quarter turn. Okay, so there's a fairly obvious point that I've realised as I was testing this in the new bush, is that this old cam spindle is obviously worn in this section inside the original steel bush, whereas this section here underneath the brake arm hasn't worn. So this diameter is actually bigger than this one. So in testing it in the bush, I'm getting a false representation basically, because this is not fitting through, but this is probably too small, if you know what I mean. So I've filed, I don't have a lathe unfortunately, but so I've just filed this down as neatly as I can on both sides, and it's now the same diameter as the worn spindle. Oops, wrong place, there we go. So yeah, that's about 12.2, 12.25. And at this end again, it's again now about 12.2, 12.25. So yeah, that should be okay now, I think. Let's give it another try. Yeah, good. That fits in. It's a reasonable fit, I think. Certainly a lot less sloppy than it was. So I'm quite staggered that this has worked at all, but it actually seems quite good. I might just tidy up these sort of ears on here, if I will tie that up. But essentially, there's a copper lining to that original steel bush. It seems to have stayed in place despite the torque from the machining. And I've now lost the bow. Yeah. So this should fit in here. Yeah, that's pretty good. Pretty good fit. Hopefully this brake arm will still fit despite the fact. Yeah, okay. I mean, it's rubbing against the copper now. But I think if anything, that would have taken up the wear on the cam itself, where it says definitely worn, especially on that side. So that used to be just a straight line across, but it's now got an angle on it and it's dished. So the copper will compensate for that to some extent. So I don't think there's any issue with having a bit of copper on the top here and on the other side. Good. Okay, so I've just reassembled the cam and the brake arm, and not surprisingly, with it done up fully tight, it's stiff. So obviously the boss with its copper on both sides is just a bit too thick. It's not far off. It still moves quite fairly easily, but it's not as free as it should be. So it should just be a question of whipping this back off again and just taking a few thou off the copper again, just to give that relief to allow this lever to be turning freely. I think I'm going to take the copper off the outside. That way I'll leave a very thick layer on here, which acts as a bearing surface for the cam. So with pressure off, that's completely free now. But so if I whip a bit of copper up on this side, that'll just give it enough relief to work properly. Okay, so I'll machine a bit off there, a bit more grease, give it another try. this time. That's the wrong way round. That's the right way round. Okay, brake arm and the nut. I'll Loctite this nut on, so decrease the threads and Loctite it on before I finish. But for now, we just check whether it's the right size. Okay, so that's near enough tight. And yeah, that's much better. It's still snug, but it moves freely. So that will be absolutely fine, I think. And now with the camera lined with the centre line, the arm is back. That's the way it fits on the bike. So the arm is just over vertical. So when the brakes are applied, it'll come through to vertical and hopefully not too far the other side. Whereas before it was way over here somewhere, so not so good. And of course this was slopping around, you could actually move this arm, you could twist it and this would rock in its bush. So that is completely gone now, it's solid now. Free to move, but there's no play where it shouldn't be. So good, I'm quite pleased with that. We'll see how it performs in service, but so far so good.